We're now ready to use the skills that we have acquired with linear equations, slope-intercept form, and finding slope and all that sort of stuff to write equations of lines from a point and a slope. So up until now we've been given the equation and we had to graph it and say what the slope and the intercept were and different things like that. And we've been investigating horizontal and vertical lines. But now we're going to come up with the linear equation from just a point and the slope. So go ahead and fill in the I can statement and let's take a quick look at the warm-up. It says graph the following equations. So we've got three of them to graph here. Notice this says y equals 3. There is no x in there. So if we have y equals a number or x equals a number, those are going to be those special cases where we have a horizontal or vertical line. And remember, you can tell what's going on here because the variable that's present tells you which axis it crosses. So if we say y equals 3, that means it crosses the y-axis at 3. Okay? So if it crosses the y-axis, it's not going to cross the x-axis. The y's always need to be 3, so we can go as far to the right and as far to the left as we want. Remember, y equals a number is horizontal. Okay, so make sure you come up with some good way of remembering which is which and how you keep those straight. X is a number, that's going to be vertical. Okay, so I'm just going to put vert right there. And then it tells us that it crosses the x-axis at 3. And again, it doesn't cross the y-axis. We can go as far up or as far down as we want. There's our vertical line right there. And then on part C for the warm-up, we need to put this in slope-intercept form so we can tell where this crosses the y-axis and what the slope is. So the first thing we're going to do is we're going to move the 3 to the other side by subtracting. So I'm going to write down y equals mx plus bu. That's what we want to make this look like. And we're going to move this to the other side. So this is going to be 4y equals, we do that by subtracting 3. So that would be minus 3x plus 8. Remember, we're going to write these in the correct order. Variable comes before the constant. We'll put that at the end. And then finally, we'll divide everything on both sides, every term on both sides by 4. Those are going to cancel, so we get y equals, then we'd have negative 3/4. Remember, we're pulling that fraction out front, those coefficients out front to make a fraction coefficient, and then plus 2 over here. So this is the equation, and now we just need to graph that. So this is going to cross at 2. There's our anchor, there's our y-intercept, and then this has a slope of negative 3/4. So we're going to go down 3 and run 4. I'm going to put a point right there. And then going the other way, instead of going down 3 and right 4, we're going to go up 3 and back 4. So that's going to put us about right there. Looks pretty good. We're going to line those up, draw a nice straight line, put an arrow on the end, and we're all set to go. Now, for today's topic, again, it's not going to be just graphing these right here. In fact, there's not going to be a whole lot of graphing on today's assignment, but we are going to be writing linear equations using just a point and a slope. So here are some key ideas that I want you to keep in mind. And this is true now and in any class you take in the future. To write an equation of a line, we will always need two things. We're definitely going to need a point, and we're going to need the slope. If you're going to write an equation of a line, you have to have kind of an anchoring point. You've got to know what point it goes through, and then you've also got to have a slope. You've got to have a way that it's tilted up or down, or really steep or really shallow or something like that. And the other thing, because we talk a lot about slope-intercept form, would be this. Slope-intercept form would be much more specific if we called it slope y-intercept form, and just instead of slope-intercept form. We could have the point where it crosses the x-axis and different things like that, but this is slope-intercept form. It's specifically talking about where it crosses the y-axis, so make sure you keep that in mind. Now, there are times where we get really lucky, and they are going to give us exactly what we need to write an equation in slope-intercept form. So this problem, it says write it in slope-intercept form, and it gives us a point 0, -2, and then it has a slope of 2/5, and then it says graph the equation. Now, if you stop and think for just a second, and keep in mind what we talked about here up above in these two key points, this right here is the slope. So we know we've always got to have the slope. So the slope on this one is 2/5. And we've got to have the y-intercept. But think about the point 0, -2. 0 means we don't go right or left. We just go down 2. So that right there is the y-intercept. They didn't say it's the y-intercept. They said it passes through this particular point. But if I put that point on the graph, that point is right there. The y-intercept happens to be -2. So remember, if you have a 0 for the x-coordinate, then whatever the y-coordinate is, it has to be right on the y-axis, because we didn't go right or left. Didn't go right or left, we just went down 2. So what that means is we can go ahead and write down the equation. So we're going to write down y equals 2/5 x minus 2. We're going to circle that and we're all set. It did say write it and then graph the equation, so let's go ahead and graph it over here. So the y-intercept is -2, and then we're going to rise 2 and run 5, rise 2 and run 5. We're going to rise -2 and we're going to go back 5, down 2, left 5. Everything lines up there. And just as a quick reminder, so you know for sure that this works, what I did there is I did down 2 and back 5. A negative divided by a negative is a positive, so that works just fine there. Okay, so we've got the right line. Now, in the box off to the side here, it says, just to be sure, how could we use the point 0, -2 to check our equation? So this all looks good. Remember, this graph is a picture of all the points that work in the equation. That is the equation. But remember, if a point is on the graph, it works in the equation, and if it works in the equation, then it's on the graph. So let's just make sure that it actually works when we plug it in. So this is an x and this is a y. So here's what we're going to do. Wherever there's a y, I'm going to put a -2. So I'm going to put a -2, and then this is 2/5. Wherever there's an x, there's calling for an x right there, I'm going to put a 0, and then we're going to subtract 2. So take a look here. 2/5 times 0. Okay, that would just be 0. So -2 equals 0 minus 2. -2 equals -2. Yes, that checks out. It works in the equation. It makes the equation true. Okay? All right, so that point definitely works in the equation, so it looks like we're in pretty good shape here. Now, we will more often than not run into things that are just a little bit more difficult. So writing an equation in slope-intercept form where we are not given the y-intercept, okay, they didn't tell us this was y-intercept, but it was pretty easy to figure out that it was. It's only just a little bit more difficult than that. So we're going to go through and do a couple of problems here, and this is the bulk of what you're going to be doing for the next little while, is coming up with linear equations in slope-intercept form just from information. And if you can do that, then you're doing really, really well. So it goes through this point right here, -5, 2, and the slope is 3/5. Now the slope is a big deal, because if we're going to write this in slope-intercept form, we basically need just two pieces of information. We need the m, we need the slope, and we need to know the y-intercept. So by them telling us that the slope is 3/5, even if we're not sure what the y-intercept is yet, we're like more than half the way there, and you'll see what I mean as we work through the next couple of sections. So here's what I like to do. I like to write down y equals 3/5 x plus b, and then I like to put a dotted circle around that. And by putting a dotted circle around that, what I'm saying is I'm almost there. I almost have this done. All I need to do is find what the y-intercept is, and I'm all finished. Okay? So here's how we find what the y-intercept is. We can find the y-intercept by remembering that if a point is on the graph, then it works in the equation. So if this point is truly going to be on the graph of this line, then it better make this equation true. So here's what we're going to do. Very similar to what I did up here when we were just checking. Now we're actually finding part of this equation by plugging this in. So this is an x and this is a y. So here's what we're going to do. Wherever there's a y, we're going to put a 2. So this is going to be 2 equals 3/5. Wherever there's an x, we're going to put the -5. So we're literally putting these xy values into that equation there, and then plus b. Now you'll notice what that does for us. It does two things. It gets rid of the y. It puts a number in place of the y. It gets rid of the x. It puts a number in place of the x. And more importantly, by replacing those two x and y's with the values that they equal in this particular point, we have an equation with one variable, and we can solve an equation with one variable. So let's go ahead and take a look at this. Let's do a little bit of simplification. 5 would cancel 5, so there would be a 1 left. So this would be 2 equals, this would be 3 times -1, so that'd be -3 plus b. And then if I move this over by adding 3 to both sides, then I end up with, let me make that look right, add 3 over here. Those are going to cancel. I get b over here, and I get 5 over here. So this is that missing value right here. So when they gave us the slope, they gave us a lot of the information about the equation. They told us how it was tilted, in which direction, how steep it was, all that sort of stuff. Okay, but they didn't tell us what the y-intercept was. By using this other point here, we plugged into that equation and we figured out, well, b's got to be 5. So we can come back here and now we can write the equation. I can take off these dotted lines right here, and I can write for sure that the equation is 3/5 x plus whatever that number is right there. We found out that b is 5, so I'm going to put a 5 right here. I'm going to circle that, and we're going to be done. Okay, so we're going to be doing this. This is a lot of algebra. This is a lot of thinking skills, but a really important thing to be able to do. So let's take a look at this next one. We're going to do the same thing, and notice that the format is the same. They told us what the point is, and they told us what the slope is. So this is a huge piece of information right here. So we're going to write down y equals negative 2/3 x plus b. I'm going to put a dotted circle around that because we're almost done. In fact, if this were a test or a quiz question and you were like, I can't remember how to do all of it, but I at least know that that's got to be the slope, you'd get quite a few points just for being able to recognize that. Now let's finish this off. This is an x value and this is a y value. So let's go ahead and plug those in. Wherever there's a y, I'm going to put a -7, and wherever there's an x, I'm going to put a -3. So I'm going to put a -7 here. This is negative 2/3 times -3, and then plus b. So now we've gotten rid of the x and the y by replacing them with a value from a point on the graph of the line. And then we've just got this variable b, the y-intercept, to solve for. So here's what we're going to do. We're going to cross cancel here. That's going to be a -1. So we've got -7 equals a negative times a negative is a positive. So this is going to be 2 plus b. And then we're going to subtract 2 from both sides. So I get a b equals -9. So I'm going to put a dotted circle on this right here, and then just remind us that all we have to do is plug that in right there. So now we're going to write down the answer. The answer is y equals negative 2/3 x, and then plus a -9. So plus a -9. That looks kind of funny right there. Let's go ahead and just write down -9. Okay? So that right there is the equation, and we're finished. That's it. So we do a little bit of this algebra work, keeping in mind where we plug in these x's and y's. We're finding the b, we're finding the y-intercept, we plug it in, and we're all done. Now, that's the work to find those. Now we're going to do a couple here where we actually find the slope-intercept form of the equation, and then we check and make sure that we got this right. So here's what we're going to do. I'm going to write down y equals -1/2 x plus b. I'm going to put that dotted circle to remind myself, gosh, I am nearly done. All I need to do is find out what the y-intercept is. I'm going to take this x and this y and I'm going to plug them in. So wherever there's a y, I'm going to put a 6. Wherever there's an x, I'm going to put a -2. And you'll notice that they've been pretty nice to us on these because they kind of always work out the same way here. So let's check and see what we get here. These cancel off. That's going to be a -1. So this is going to be a 6. -1 times -1 is a +1 plus b. And then finish solving this by subtracting 1. So we get b equals 5. Okay. Now I'm going to take this and I'm going to plug that in right here. So here's the answer that we're after. -1/2 x, there's our slope, and then we figured out that our y-intercept is 5. So I'm going to put a circle around this right here. So unlike the two that we did up here, this actually has a graph, and it says go ahead and graph this, and then we're going to make sure that we did this right by having a little bit of a double check right here. So this is going to cross the y-axis at 5, and I'm going to go ahead and make this a little bit bigger. So it crosses the y-axis at 5. There's our y-intercept, and the slope is -1/2. So we're going to go down 1 over 2, down 1 over 2, down 1 over 2, and so forth. Up 1, back 2, up 1, back 2, up 1, back 2, doing that rise run to get the whole line right here. So it's going to look something like this. Okay, tough to graph perfectly on a piece of paper like this, but that doesn't look too bad. Okay, so we've got the slope-intercept form of the equation, and we've got everything we need here, but let's do a double check right here. I'm going to change colors right here, and we're going to graph this point right here. We're going to graph -2, 6. If we did this right, that point had better be on our line. So let's double check and make sure. -2 on the x-axis, we're going to go left 2 from the origin, and then we're going to go up 6. Here's 5, here's 6, and there's that point right there. It works. It makes the equation true. It's on the graph. So we definitely did this one right. We're in really good shape there. Okay, let's do the same thing again on this one over here. So we're going to run through and we're going to start with the information that they've given us. This is the biggest piece right here. They told us what the slope was. So let's write y equals 4x plus b. I'm going to put a little dotted circle around that to remind me that I'm almost done. This is the x and this is the y. So wherever there's a y, we're going to put a -9. Wherever there's an x, we're going to put a -2 plus b. So this is -9 equals, nothing cancels here, so that's kind of nice, -8 plus b. We're going to add 8. So that's going to be -1 equals b. And this is the final piece of information I need. Remember in the last unit they would say, okay, here's the slope, here's the y-intercept, just write the equation. Now we have to do a little bit of work to get to that point, but we've got it now. We plug it in right there, so we get y equals 4x minus 1. We're going to circle that. That's the answer. Let's go ahead and graph this. Here's our anchoring point, -1. And then the slope is 4. I'm going to write this as 4 over 1. So we're going to rise 1, 2, 3, 4 over 1. Really steep in that direction. 1, let's see, did I get that right? Yep. 1, 2, 3, 4 over, and somewhere around right there. And then going the other direction, down 4, back 1, down 4, back 1. Looks like everything lines up, so we're graphing this the right way. And then we just have one quick thing to double check. Is this point on our graph? So if we went back 2 and went down 9, take a look, there's -5, 6, 7, 8, 9. We're right on there. Okay, so it's on the graph. It makes the equation true. We are in great shape on that one. Okay, so how can we use the information from the problem to check our equation? Plot the point on the graph. Plot the point on the graph, and if it's on that line, then we know we've done it right. Okay, so this is our way that we can double check. Okay, so I'm just going to write double check here. That's our double check, is we make sure that the point that they gave us in the information actually is on the line that we predicted. Okay, good luck with the assignment.